In my last video tutorial, we drew section lines on our first floor drawing shown on the screen. We drew section AA and section BB, and you see the section AA at the top of my screen and section BB below the screen. In this tutorial video, I'm going to explain to you how to calculate staircase load from your general arrangement drawing on AutoCAD, and I'm going to also show you how you apply this calculated load on your Orion 18 structural module in this project. So I will now we'll start from we have two types of staircase for this building project. We have a staircase that is located on my left hand side here, and a staircase that is located on my right hand side. I'm going to start my explanation with the staircase on the right hand side. The staircase on the right hand side is an half-turn staircase. I will show you the staircase on my AutoCAD drawing now. This is my first floor GA, and this is the staircase. Has 2 flights and a half landing slab. And the slab, I'll show you my general arrangement drawing for the half-turn staircase. This is the half-turn staircase. You can see that the staircase is designed to be linear supported. A beam is provided at the end of the stairs, and also a beam is also provided there. So our objective is to determine the load of these flights and landing. The load that will be transmitted from the flight and landing on these two beams, the beam here and also the beam here. So to do that, I've already done some calculation on Microsoft Word on how to compute staircase loads. So if you look at what is on your screen, the heading is loading on staircase. For the flight element, the flight element of the staircase is this inclined element. For each of the story, like this beam is supporting 2 flight elements. Like this beam and this beam is supporting, each of the beams support 2 flight elements and an half landing slab. So I'm going to calculate the weight of 2 flights and a half landing slab, and I'm going to distribute the load between the 2 beams. So in my calculation, you'll see for the flight, the first weight I calculated is the waist slab weight. The waist is the flight. This is what I mean by waist. The waist is the thickness of your flight element. From let me use a line from this point from this edge to this point, 200. So the waist is 200. The waist is the thickness of your flight element. So and the waist is 200 mm. So I'm going to show you how I computed the weight of the flight element. So I say waist slab weight. My unit weight of concrete, I'm using 25. So what I'm calculating here is the weight per meter square. So I'm just multiplying by the thickness of each of the elements. So the unit weight of concrete is 200, which is 0.2 meters. Will give me 5 kilonewton per meter square. Now the step is the triangular element on the flight. I will show you on the drawing. All this triangle on the flight, each of them, all this triangle, these lines, all these triangles, they are the steps. So we are going to calculate the weight of that, these elements. So it's triangle. So how you calculate it, like half base times height, half times the riser, You don't need to multiply by so half times the riser times the unit weight of concrete. I'll show you on my drawing. Half 0.5 times the riser is 155 mm times the unit weight of concrete. So give me the weight of the steps, the triangular element in kilonewton per meter. So this is the value. The finishes I'm using for my step is 0.6 kilonewton per meter square. Now I say steps plus finishes. As in steps plus finishes, 1.938 plus 0.6 to give me 2.538. So you also need to calculate a factor called slope factor, and it's given by this formula. R is the riser, T is the thread. So our R for the staircase is 155, and our T, the thread, is 300 mm. So if you calculate it, we get 1.125. Our live load that we're using 5 kilonewtons per meter square. So dead load for planned area. So I want to calculate the dead load. The dead load for plant area would be as in the sum of all the dead load. That is the weight of the waste slab weight, the steps and the finishes. However, we need to factor the step and the finishes by the factor, by this slope factor. So I will say 5. 5 is the waste slab weight plus the factor multiplied by the weight of the step and finishes. 2.538 is the weight of the step and finishes. So that's how you get the dead load for planned area for the stairs, which is 7.88. Um, we need to calculate, I want to calculate the load in kilonewtons. So I want to know the area covered by the flight element. I calculated the value from AutoCAD as 7.91 meters square. I will show you how I calculated it on AutoCAD. If you go to the first floor GA, the area, the area is what you are seeing on the screen, what I'm highlighting for the flights. The flight is the stair part of it, not the aft landing. So what is highlighted on the screen is the area of flight. So I want to know this area. So how will you do that? You use your measure command for area under your utility panel. So I'll click on area, and I'll click on where my beam at my full landing beam, where it connects with the column. I'll click on that point. Click on this point. Click on this point. Click on this point. So what is highlighted now is my planned area for the flight. If I click on enter on my keyboard, but if I click on enter on my keyboard, I get the value of my area. You will see area, you will say 7910950. This is in mm square. The value is actually 7.91 meter square. In meter square, it is 7.91 meter square. You do your conversion, convert mm square to meter. I'm not doing it for you. So this area is 7.91 square. So that's how I got 7.91 square here. So after I've gotten my square area for the flight, let me change this for the flight. Then I calculated the load in kilonewtons by multiplying the dead load and the live load by this area. So the total dead load is what we have calculated here. Dead load for planned area 7.88 say 7.88 times the area 7.91. If you do that, 7.88 times 7.91 will give you 62.33. So I will change this to 62.33. 62.33. The total live load will be we say that our live load is 5 kilonewtons per meter square. So 5 times that area, 5 times 7.91 will give me this. So this is for the flight. For the aft landing, the weight will be the slab weight. We are using a thickness of 200 mm. So our weight per meter square will be 25 times 0.2. So we get 5 kilonewtons per meter square for the slab dead weight. Finishes, let the finish be 1 kilonewton per meter square. I want to be a little generous than this 0.6. Let it be 1 kilonewton per meter square here. The live load, let it be 5 kilonewtons per meter square. I do not need this field. Let me remove it. I don't want it to confuse you. So once you have calculated, we have calculated our dead and live load. Then the square area of flight, I got it to be 4.1 meters square on AutoCAD. I'll show you how you calculate that area on AutoCAD. So this is the landing area. I'm going to use the area measure command to measure the area. So from the first riser, from the riser area here, this point, I'll click on that point, click on this point, click on this point, click on this point. So this is my area, 4.08. So 4.1 meters square. So that's why I got 4.1 meters square as my square area. So you multiply this area by your total dead load. My total dead load for the half landing is 5 plus 1. My dead, the finish is a dead load, the slab is a dead load. So 5 plus 1 is 6. So total dead load is 6 times 4.1. Give me 24.6 kilonewton. Live load will be 5 times 4.1. I'm using 5 as my live load. 5 times 4.1, which will give you 20.5 kilonewton. So this is the important part. Please make sure you understand this statement. I say the stair is supported by two beams, and the half landing beam and the full landing beam at the floor level, and half landing beam and the full landing beam at the floor level, and at the longitudinal direction of the beam, the longitudinal direction of the stair, sorry, of the stair. The beam is located longitudinally along the stair. And we assume the dead and the live load calculated above are shared equally between these two beams. So the beams are the supporting element, and I assume this dead load here, the dead load calculated for the flight and also the dead load calculated for the half landing, they are shared equally between the two beams. So if I say dead load carried by each beam in kilonewton per meter, so this is in kilonewton per meter. Sorry. So dead load carried by each beam in kilonewton per meter. The length of my beam from AutoCAD is 2.5 meters. I will show you. AutoCAD. My beam is located between these two columns. I should use the distance measure command. From grid to grid, you see it is 2.5. Also, my full landing beam at the floor level is also 2.5. From this point to this point, 2.5. So the length of my beam is 2.5 meters. So if you want to calculate the load carried by each of the beam, is simply the dead load carried by each of the beam in kilonewton per meter. I will say the total dead load for the flight plus total dead load for the landing. So 62.33. Let me change it to 33. 62.33 plus 24.6 over 2 times 2.5 will give me this value. The live load carried by each beam is kilonewton per meter, not per meter square. Will be live load of the flight, live load of the half landing, divided by 2. Now I'm sharing it. Now I'm dividing by 2, but you divide it. You also divide by 2.5. You will get this value. Let me quickly correct this dead load for the dead load carried by each beam because I edited this value. So I'm calculating it now. Let me use my calculator on my laptop to calculate it. 62.33 plus 24.6 divided by 2 divided by 2.5. So I have 17.39. So 17.39. So this is the load I'm going to apply on each of my beam at the half landing and full landing for the half turn staircase. This will be part 1 of applying load on the half for the half turn staircase. We are going to apply this value of dead load and live load for the beam in my next session. That will be part 2 of this tutorial session. Thank you for watching.